Okay, let's get straight into it. Look at this real past paper question right here. It looks standard, right? But it is a trap that catches out thousands of students every single year. Today, we are mastering one of the absolute most foundational, yet surprisingly tricky areas of the Cambridge Computer Science syllabus. We're zeroing in on subject code 9618. But listen, whether you're taking 0417, 0478, 0983, 0984, or 2210, the principles we are covering today are the bedrock of your programming and algorithmic problem solving. We're talking about data types. Integer, real, char, string, boolean, and date. Now, these show up in every single exam series, guaranteed. But here is the real secret to top-tier A-star exam mastery. Are you ready? I want you to completely change how you view yourself. Stop thinking like a student and start thinking of yourself as a master fashion designer. Seriously, think about it. When a VIP client comes to a high-end designer, they don't just want a generic, mass-produced piece of fabric. No way. They want a suit or a dress tailored to fit their exact measurements perfectly. Absolutely no loose threads. Your exam answers need to be exactly like that, perfectly tailored to the very specific context of the question you're given. No generic answers allowed. Too often, I see students fall into two distinct, really frustrating camps. First, there's Alex. You probably know an Alex. Alex is absolutely brilliant at memorizing raw computer science facts. But in the exam, Alex completely overloads the page with massive, untargeted brain dumps of information without any actual analysis of the context. It's a mess of red pen. Then there's Sam. Sam gets nervous, rushes through the paper, completely misses the specific command word requirements, and just throws down literally the very first data type that comes to mind. By the end of this explainer, you are going to learn exactly how to avoid the deadly traps that both Alex and Sam fall into, and we're going to transform your exam strategy entirely. This quote you're seeing right here, this is pulled directly from the core principles of the Cambridge syllabus. It's the examiner's ultimate wish list. Top-performing students exhibit connected, conceptual understanding transferable to unfamiliar contexts. Now, what does that actually mean for you when you're sitting in that silent, stressful exam hall? Well, it means that just knowing the textbook definition of an integer or a string is simply not enough anymore. Literally anybody can memorize that an integer is a whole number or that a string is a sequence of characters. But the examiners aren't just testing your memory. They are rigorously testing your assessment objectives, specifically your cognitive domains of application and analysis. When you turn the page and are presented with a completely bizarre, totally unfamiliar scenario, maybe it's an automated system managing the temperature fluctuations of a deep-sea submarine, or a massive database tracking the exact millisecond a low-orbit satellite crosses a specific coordinate. You have to seamlessly transfer your conceptual understanding of data types to that exact highly specific scenario. Our student Alex struggles so hard here, because Alex just recites the textbook. Alex writes down what a real data type is, but completely fails to explain why it's the absolute only valid choice for capturing the continuous fractional data of a submarine's temperature sensor. To get those high marks, to get that green check mark instead of the red pen, you have to actively connect the core concept to the specific context. Okay, let's dive into this. To get you to that top-tier A-star level, we are going to follow a very specific step-by-step roadmap today. First, we will tackle the data types challenge, looking at the common pitfalls. Second, we will introduce the procedural framework, your ultimate success blueprint. And third, we will cover critical analysis and evaluation to push your grade to the absolute maximum. Let's jump right into our first major hurdle. Section 1, the data types challenge. We need to navigate the traps that are catching everyone else out. Now, pay close attention because what's really interesting here is that this gives us a direct, unfiltered look right into the examiner's mind. This is an official red flag examiner alert. Principal examiner reports reveal year after year that candidates consistently confuse key terminology. You must, absolutely must, always define your terms before using them in your extended responses. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, back to the strategy. Let's look at our rushed student, Sam. Sam gets a question asking to justify the choice of data structures for a complex hospital booking system. Sam panics, rushes, and immediately writes a messy, unstructured paragraph about using arrays, completely mixing up chars and strings without ever defining what those terms actually mean in the context of the hospital. Think about it. Does a CHAR represent the single-letter blood type of a patient? Does a date data type handle the specific appointment time? Sam loses all the method marks because the terminology is tangled and vague. This is where you need to apply the Peel framework. Point, evidence, explanation, link. Your point should clearly establish the correct terminology right out of the gate. If you are using a Boolean, state clearly that it is a data type with only two possible values, true or false, and then seamlessly link it to the fact that the hospital patient has either checked in or they haven't. Clear terminology is your unshakable foundation. Let's break down the top 3 examiner warnings when it comes to handling data types. This is exactly where the red pen comes out in force, completely destroying candidates' mark schemes. Number 1, using the wrong formula or algorithm for the specific context. This usually happens when you lazily choose an integer division when the scenario actually heavily relied on a real data type to capture the exact remainder for a hyper-precise calculation. Number 2, forgetting to check boundary conditions and edge cases. Listen, if you declare an integer for a user's age, what exactly happens if the user accidentally inputs a negative number or a 0? Have you actually accounted for that in your algorithm's validation routines? Probably not if you're rushing like Sam. And number 3, the absolute biggest trap of all, providing answers not specific to the given context. This is that loose thread in our fashion designer analogy. If the exam explicitly asks about a local library management system and your answer talks generically about saving memory space, you score a flat 0. You need to say something like, using a date data type rather than a generic string for the book return deadline allows the library's algorithm to perform chronological calculations to automatically generate daily overdue fines. Do you see the profound difference there? That is a perfectly tailored, context-specific answer with no loose threads. So now that we deeply understand the traps, let's talk about how to systematically secure those marks. Section 2, the procedural framework. This is all about locking down those critical method marks. And this brilliantly illustrates the exact standardized processing sequence you must execute to secure what Cambridge calls method marks. You see, examiners award points for the logical process, not just the final isolated outcome. Step 1, identify key elements. You have to extract the data types hidden deep within the question text. Step 2, apply relevant principles. Make a hard decision on whether a real or an integer is mandated by the context. Step 3, execute your analysis with crystal clear working. Step 4, verify your results. And Step 5, present it all in the appropriate format using correct, flawless technical notation. This 5-step sequence maps perfectly onto the Peel framework we discussed just a minute ago. You make your point by identifying the core element, you provide evidence by applying the correct computer science principle, you explain thoroughly through your step-by-step analysis, and finally, you link it all back to the specific format the exam question demanded. Master this computer science success blueprint, and your answers will magically transform from a chaotic mess of red pen into a beautiful, uninterrupted column of green checkmarks. Within that procedural framework, algorithmic thinking is absolutely essential. It's the engine driving your answers. Let's look at the 4 crucial pillars here. First, step-by-step decomposition is about taking a massive, overwhelming problem and systematically breaking it down into smaller, highly manageable chunks. Next is appropriate data structure selection. Now, this is where your true mastery of integer, real, char, string, boolean, and date truly shines. Think about this. If you were asked to store a customer's telephone number, do you use an integer? Absolutely not. Why? Because phone numbers often start with a 0, which an integer data type would automatically drop, completely altering and corrupting the data. You have to use a string. Or what if you are tracking whether a specific smart home light bulb is on or off? You don't use a bulky string that literally says on or off. That incredibly wastes memory and processing time. You use a highly efficient Boolean. Efficient code implementation and rigorous testing, including boundary and erroneous data testing, round out these essentials. Every single choice of data type has a massive cascading effect on exactly how efficient your code will be and how rigorously you can actually test it. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE, to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. All right, let's keep the momentum going and see how this framework directly builds your data interpretation skills. In the exam hall, you aren't just going to be writing code from scratch. You will be critically interpreting complex existing data. Let's do a quick interactive workshop exercise right now. Challenge number 1, the data scan. I want you to imagine a complex computer science data table on your screen. It's showing raw memory addresses, dense binary strings, and ASCII character codes. I want you to imagine a 60-second visual countdown timer running down right now. Your challenge is to execute a rapid data scan. You have to extract the core trend immediately. You need to be able to look at a raw binary sequence and instantly recognize if it's representing a positive integer, a 2's complement negative integer, a floating point real number, or a single char, all based on the specific context provided in the question's header. Once you extract that core data within that 60-second window, you perform your calculations and, crucially, this is the most important part, you draw a solid, evidence-based conclusion. You must state explicitly on the paper exactly why the data is behaving the way it is. This precise extraction and explanation is exactly what separates a mediocre passing grade from a definitive A-star. We are now moving into the final, most crucial phase, where the top candidates really differentiate themselves from the pack. Section 3, Critical Analysis and Evaluation Strategies. So the crucial point here is understanding the vast, noticeable canyon between an average candidate and a truly top-scoring candidate. Let's jump into our second interactive challenge, Find the Flaw. I want you to critically evaluate this sample paragraph from our rushed student, Sam. Sam writes, and I quote, "I will use a string to store the customer's choice from the A, B, or C menu because it holds letters." Okay, time's up. What is the fatal flaw there? Why does that instantly lose marks? Well, the top-scoring candidate looks at that exact same scenario and immediately analyzes the hidden trade-offs. The top scorer writes, "While a string could technically hold the menu choice, a CHAR is the optimal data type here. A CHAR restricts the input to a single character, inherently limiting erroneous input length, and consumes significantly less memory space than a dynamically allocated string, making the overall algorithm much more efficient." Boom! Do you see the massive difference there? The top-scoring candidate considers multiple viable solutions, expertly analyzes the trade-offs regarding memory allocation and processing efficiency, openly acknowledges the system's limitations, and justifies the final decision with concrete technical evidence. They don't just provide generic copy-pasted textbook answers. They tailor the logic beautifully to the specific problem at hand. To reliably achieve that incredibly high level of evaluation, you must adopt the ultimate problem-solving sequence, the Deconstruct, Solve, Evaluate framework. For our third challenge, imagine a 30-second speed writing timer ticking down on the screen. When you first look at an exam question, your immediate action is to deconstruct it by identifying the given information and command words, breaking it into logical steps. Then you solve it systematically. But steps 4 and 5, that is where the high-level evaluation actually happens. Check for reasonableness. Let's be real here. If your algorithm outputs a real number, like 5.5, for a variable specifically tracking the number of human passengers on a bus, your fundamental data type logic is completely flawed. You cannot have half a passenger. You must use an integer. Finally, make justified recommendations. If the exam explicitly asks you to improve an existing algorithm, you should recommend changing inefficient string comparisons to lightning-fast Boolean flag checks, and then justify exactly why that specific change drastically improves the algorithm's time complexity. This ties perfectly into the 3 rules that guarantee CHAR marks. Number 1, command word decoding. Number 2, rigorous Peel framework application. And number 3, utilizing a time management matrix so you actually have the minutes left to write these detailed evaluations. We are now arriving at the absolute secret to high marks, a strategy pulled straight from the underlying architecture of the Cambridge syllabus itself. The theoretical architecture of this entire syllabus rests on 3 pillars: precise definitions, causal relationships, and integration. Principal examiner reports continually highlight that candidates who boldly reference cross-topic connections achieve significantly higher marks overall. This means you don't just talk about a date data type in isolation. No, you connect it directly to database design, explaining how that date acts as a sorting mechanism or a primary key. You connect Boolean logic variables directly to Boolean algebra and hardware logic gates. You connect real and integer types to file handling, explaining precisely how different data types require entirely different serialization methods when writing to a plain text file versus a raw binary file. When you actively weave these different topics together in your extended answers, you prove beyond a shadow of a doubt to the examiner that you are a master of the entire syllabus, not just someone who memorized a stack of flashcards. As we wrap up this explainer, I want to leave you with a final, highly provocative question. I want you to go look back at your most recent past paper attempt. Seriously, go look at it. Are your answers perfectly tailored to the question's specific context with absolutely no loose threads, or are they full of holes? Have you actually moved past Alex's generic factual brain dumps and Sam's nervous rushed mistakes? By strictly adhering to the Peel framework, deeply evaluating your algorithmic choices, and truly understanding the real-world applications of these data types, you can and will achieve those maximum marks. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the exams. Your Cambridge success starts here.